Good morning, and thank you for joining us. By the end of this talk, I hope to convince you of two things. The first is that your job is not all about writing code. And the second is that TDD is not all about testing. Let's dive straight into business. What is design? Is this design? Is this design? Well, obviously not, right? So let's go to the supreme authority and ask Wikipedia what is design. So Wikipedia says that software design is the process of implementing software solutions to one or more sets of problems, blah, 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 blah. That's hardly helpful. That's not design. So let's try another approach. Growing Object-Oriented Software Guided by Tests is a book that at Wix Backend Engineering we consider to be somewhat of a Bible. And we hand a copy, hard copy of this book to each new recruit. And we ask them to read the book and hopefully to implement the software project that it describes. And in Goose, Ned Price and Steve Freeman liken software engineering to gardening. So when you write software, according to Ned Price and Steve Freeman, you're not building a bridge, you are cultivating a garden. And I really like this analogy, because if you think about it, mankind over the years has taken plants such as wild cabbage and cultivated it into many different plants or vegetables that we eat today, like broccoli and cauliflower and kale and kohlrabi and Brussels sprouts and whatnot. And this is a very nice analogy, in my opinion, because it describes the fact that software evolves rather than being built. When you build a bridge, when you build an electrical circuit, you build it and then it's there. But when you build software, you don't just build your software, you maintain your software, you evolve your software over time. So this is a very nice analogy in my opinion, but it has a problem because where does design come into the picture? We learned that to design software, you need to write documents and to draw diagrams and UMLs and charts and all of that. But that does not really sit well with the concept of gardening, right? So let's ask another one of these esteemed gentlemen that I like to refer to. Michael Feathers wrote a book about working with legacy code, and according to Michael Feathers, legacy code is any code that has not been tested, has not been developed with tests, is not covered by tests. The act of programming is actually design. When you code, when you write tests, you are designing your software. And he likens that to building a bridge, which is contradictory of what I said before, but bear with me here. When building a bridge, an engineer draws diagrams, and then a manufacturing team comes into the picture and actually builds the bridge. And traditionally, in the software industry, we thought that the architect that writes the documents is the engineer, and the coders, the programmers who implement the software solution are the construction team. And Michael Feathers says that this is not the case. Actually, the documents and the charts and the UMLs are all just views or projections of the design. But we, the coders, are the engineers. And the manufacturing team is actually our compiler or our interpreter. And because we misunderstood the concept of what design is and what manufacturing is, we waste a lot of time on writing these documents and drawing these diagrams, which lose touch with the reality of our software as soon as they've been written. Right? We've all seen that. We've all read or even written design documents that had nothing to do with the software that we actually produced. So what is the implication of this? Well, to code is to design. And when we grow our software, the design for our software emerges from that evolutionary process that I described. Now, software will grow, and whether we like it or not, it will grow. It grows as we receive change requests or new features, or we detect bugs. And if and our job in this process is to water and fertilize and trim and prune our garden of software. Otherwise, it might rot, it might decay. And if we do not do that, if we fail to fertilize and trim and prune our garden, then we might end up with a big ball of mud. Now, a big ball of mud is a term used to describe software that has lost all design. It lost all touch with the concepts that was originally thought about when designing it. And now when you want to change it, when you want to add new stuff to it, you just patch it anywhere that it works and you let it be. And I've referenced in the footnotes of this presentation, which will be available, of course, afterwards, I've referenced an essay that talks about big balls of mud, and I really recommend that you read it. It's fairly long, but really, really inspirational. What are big balls of mud? What is the problem with them? And how we do not get to the state of big ball of mud. If we go back to the main thread, requirements will change. This is a fact of life. This happens in any project. Now, we know that early design decisions that we make about the implementation of our software has a bigger impact than later decisions. Much like when there's a mutation that occurs in an embryo in the womb, it's much more destructive than the same mutation when it happens in someone who is 30 years old. So it's better off if we defer or wait with the big implementation decisions about our software, and we focus initially on our interfaces. Now, these do not have to be Java strict formal interfaces. Even in JavaScript or Python or non-compiled languages, we have interfaces. We just don't call them necessarily interfaces. But if we focus on the interfaces and wait with implementation decisions, we are probably going to have an easier job letting our software evolve and grow over time. Now, this brings us to outside-in development. And a lot has been written over the web about outside-in development, but basically it boils down to writing code from the call site. So first, you write code that uses the code that you're going to write, and then you implement that code. I really recommend that you always try to do that. You always try to write code from the call site. You always first use your code and then implement your code, because this is what's going to help you stick to the interfaces rather than to the implementations. And I like to look at it like a sculptor who builds a statue. So we take a block of marble, and we take a hammer and a chisel, and we start carving into that block of marble, and we end up with a very nice statue. And us as software engineers, if we write code from the outside in, we end up with our technological stack. Now, that technological stack might be a Java, MySQL, Linux system, but it might as well just be a couple of classes. The principle stays the same. We write from the outside in, and we end up with a technological stack that actually answers what we need to answer. We don't decide in advance that we're going to use a Spring framework and Hibernate, for instance. We first write our software, and then we decide how we're going to implement or solve any specific problems. Outside-in development also helps us with two other very important things. First, when you do outside-in development, you end up with software that is more cohesive, that is loosely coupled, that is basically solid compliant, that is better engineered. And second, it helps you maintain YAGNI compliance. Now, what is YAGNI? YAGNI stands for you ain't going to need it. Now, I think that you've all been there. I know that I have. We've all written software that we don't need because I'm going to need it later, right? No, you're not going to need it later. You may need something like that later, but it's not going to be what you're writing now. So don't do it. And I'm going to give you an example. Let's say that I need to develop a library system for lending books. So it's going to be a web-based library. So I'm going to use a Spring MVC or something similar. I'm going to write a book controller, and I'm going to write a book service, and it's going to have some methods that encapsulate the business logic of my system. And then I'm going to have like a book DAO that abstracts away database access, and it's going to have, create book method, and a delete book method, and an update book method, and find book by author, and find book by name, and find book by ISBN. And do I even need any of these? Well, no. I need to be able to lend books to people. So right now, I've violated the YAGNI principle. I've written methods in advance that I didn't need. And most likely, I'm not going to need these specific methods later on. I'm going to need other methods. Now, the problem with YAGNI is what we like to call in Hebrew preparation for an air conditioner, or הכנה למזגן. What's wrong with laying down infrastructure for an air conditioner before you actually need the air conditioner? Well, you might have laid down the wrong type of ducts or of gas pipes. You might have laid the ducts in the wrong place. The electrical circuit might be the wrong type or in the wrong place. And most often, we end up with stuff like this. There's an air conditioner, and then there's the extension ducts and cables or cords, and maybe you have to carve the wall. And in software industry, I look at the worst type of YAGNI violations are the premature indirections that we do. Introducing a book service, introducing a book DAO when it is not yet needed, will later bind us and commit us to these indirections, which are not the necessary indirections. These are not the abstractions that we need. These are the abstractions that our over-engineering and pattern abuse has led us into writing and into embodying in our software. And I think that this is a major sin in our industry. We do that a lot. We take the mechanical concepts of how we developed software in the past, and we force them on the software that we are writing right now. I think that this is really one of the key problems today in software engineering. And I think that we need to focus more on the mechanics, more on the semantics of what we're doing than on the mechanics of how we're going to do that. And how outside-in development helps us with doing that. It helps us focus on the semantics rather than the mechanics. It helps us focus on the abstractions rather than the indirections. It helps us form a language that describes the problem domain in specific terms to that language. It helps us talk about a librarian rather than a book service. Now, if I use the librarian term to describe what I'm doing, then I'm probably not going to be tempted into putting stuff there that does not belong with a librarian. Maybe stuff like maintaining books will go elsewhere. Maybe stuff like creating books will go elsewhere. Naming matters. Naming affects and directs our thinking. As soon as we've named something, we have committed ourselves to that specific form of thought about what we are doing. When we are YAGNI compliant, when we do not do anything in advance that we don't need, when we work from the outside in and creating our abstract language, then it's much easier for us to leave out the stuff that does not belong in our software. It's much easier for us to maintain that and keep maintaining that specific language that describes our code. It helps us stick with interfaces rather than with implementations. And I think that your job as engineers is not to write code. Your job as engineers is to introduce these semantic abstractions. This is the most important thing, I think, that I'm going to talk about today. Unfortunately, old habits die hard. As engineers, we grew up reading books like the Gang of Four books, book about design patterns, and using, Java monstrosities like Spring Framework and Hibernate and stuff like that. Patterns and technologies are cool, and we want to use them. Maybe we shouldn't. Maybe we should first think about what we want to solve, and only then about which new and exciting technology we're going to use to solve that problem. I think we need a paradigm shift as an industry to help us shake off pattern abuse and over-engineering and help us be more YAGNI and focus on the semantics rather than the mechanics of software. And I think that TDD is the way that you can do it. It took me some time to realize actually what TDD is. I've been claiming that I've been doing TDD for the past 6 years or so, but just only in the recent couple of years, I've really understood what TDD is. So first, let's talk about what is not TDD. First and foremost, and I think this is consensus by now, if you write your production code and only then write your tests, you are not doing TDD. The opposite is also true. If you write all of your tests for a system, for a class, for a module, and only then implement the entire thing, you're making exactly the same mistake, but from the other end, because you're making assumptions that are not based on any hard evidence. You will be writing, 10 or a dozen tests, and then you implement the first couple of tests, and by then, the third and fourth test might not be relevant anymore, but you've already written them, so you are mentally committed to implementing them. And so you're making assumptions that are not necessarily true. Another problem is writing end-to-end tests that are tightly coupled to the implementation of the system, or writing a lot of end-to-end tests that all run through the same code paths. And this is something that we see in JavaScript communities and in Ruby on Rails communities, because it's very easy to just start up the system in sub-second times and then just start exercising it. But this is very problematic, because when you do that, then the same tests, as I said, like hundreds or dozens of tests exercise the same code paths. And then, if I need to make a change that affects one of these code paths, all of these tests are going to be affected. So writing a lot of end-to-end tests that exercise a lot of code paths will make it harder for you to make changes to your code. So you should prefer writing a few end-to-end tests and a lot of internal tests, like unit tests or integration tests. And finally, and this is something that we've been doing wrong at Wix. If you write end-to-end tests for microservices, but not for the entire system, if you don't have tests that cross from the UI to the server and back, then this integration between the client and the server is where you're going to have bugs. So it's perfectly fine to write tests for microservices, but these do not come instead of end-to-end tests. These are contract tests or component tests or acceptance tests, and they're really important, but you gotta have an end-to-end test, and you gotta start with an end-to-end test for the entire system. Otherwise, you're gonna have bugs in these exact same places that are not covered by tests. So TDD, what is TDD? TDD started as a spin-off of extreme programming back in the 1990s. Kent Beck is credited with coining the term by somewhere around the turn of the century. Today, many of the people who do TDD actually don't know anything about extreme programming, myself included, but that's perfectly fine. Some important figures in the TDD world are names I've already mentioned, Ned Price, Steve Freeman, Kent Beck, and Martin Fowler, who we are going to mention later. How did we start doing TDD at Wix? So I joined Wix in August 2010. And when I joined Wix, we had 4 backend services. We had an editor, we had a public, we had a user service, and we had a billing service. And the public service was a big ball of mud. It was one class with 3,000 lines of code that, for the life of me, I could not understand if I take a given set of inputs, what's going to happen. It was completely non-deterministic. And we used to do what I call prayer-driven development. We used to make a change to the public server and then deploy to production and pray that it's not going to break. And many times it broke. And many times we had to roll back, and that caused downtime, and that caused us to lose money. So that couldn't go. We had to do something about it. So what we did was we took all of the knowledge, the undocumented, unwritten knowledge that we had at Wix about how the public server should behave, and we embodied this knowledge in a set of end-to-end tests that ran against a staging environment. And these tests gave us a very good safety net. And then we started going from the outside in. We made these tests run as part of the build of the public server. And then we started carving in. And we could be sure that nothing is going to break because we had end-to-end tests that asserted that everything is going to be OK. And by the end of 2011, we had a system that was covered completely with unit tests. It ran like this. And I think that since then, there have been very, very, very few occasions where we had bugs in the public server in production. And I looked at the code recently, 5 years after that major refactoring, and it still looks, majorly it looks nice. Because the code is covered by tests, and because the code was written was refactored from the outside in, it has not rotten too much. So that convinced us that there is something to TDD. So we went and we hired the TDD guru. And this guy came in and told us, no, guys, you're doing it all wrong. You are writing your test after writing your production code, and you're writing too many E2Es. And you do not have end-to-end tests that cover the client and the server. So we were smart and experienced and individuals that we knew exactly what we were doing, so we completely ignored what he said, and we went on doing exactly the same. And so he said, you know what, forget it. I'm going to do my own thing, and you're going to do what we want, and then we'll see. And so he went and he wrote P3. And P3 is Wix's production experimentation system. And P3 was developed TDD by the book. And then, I think, the penny dropped. We realized that it was really easy to make changes to P3 and to add new features to it. And then, we really understood what TDD is all about. And nowadays, I'm very proud to say that TDD is a major part of our training program. And people that go to Wix Academy learn about TDD, and people that come into the back engineering group are requested to read Goose and implement the project. Let's talk a bit about the TDD lifecycle. We all, I think, know the three-colored hat. Uncle Bob is famous for popularizing this concept. And in TDD, we're talking about a cycle of 3 phases: test, code, refactor, and then repeat. But if we're going to develop software from the outside in, then we're going to start with an end-to-end test for a software system that does not exist yet. How do we do that? How do we write a test for a system that does not exist? So we pick the first use case. And I'm going to talk later about what is that first use case and how you pick it. But let's assume now that we have a first use case. And we write a failing end-to-end test for that use case. Now, this failing end-to-end test is going to be in English. It's going to talk about the problem domain, meaning it's going to talk about, in case of a library, it's going to talk about books and lending books. It's not going to mention databases. It's not going to mention HTTP. It's not going to mention Linux. It's only going to mention the semantics of our software. And it will not pass, obviously, because there's no system. It will not even compile if you use a language like Java, because the test is going to exercise a system that does not exist yet. This is perfectly fine. This is OK. This is what we want. In this phase, what we want is to make sure that nothing in the test is tying us to the mechanics of the system that we are going to build. Next, we implement it. We make it pass. And we do it from the outside in. And we write the simplest code possible. We don't think about design. We don't think about engineering. We don't think about design patterns. We don't think about Spring Framework or Hibernate or databases or anything. We make it work. It's going to take some time. In complex systems, it took me, a couple of weeks to create that first, to make that first failing test pass. But this is perfectly fine, because it's time that is well spent. It's time that you're not going to spend later on integration problems, because when you finish with that failing test, when you make that first failing test pass, what you have in your hands is the working skeleton. It's a very thin slice of functionality, but it's the entire system, from the user interface to a database or whatever you use for persistence, and all the way back. And it's already integrated, and it's already deployed to production. And so adding new features to it is going to be much, much easier. So it's perfectly fine that it's going to take some time. And many complexities that we didn't think about at this stage will be teased out by the mere act of creating this working skeleton. And if we're talking about a later cycle of TDD, then we might have added new functionality to existing system. We might have copy-pasted some code. This is perfectly fine. Copy-paste at this stage is perfectly fine. Because then we get to the real point. Then we get to refactor. And what we do is that we look at the code that we just wrote, and if we are talking about the latest phase of TDD, then any code that has been affected by that first, by that test that we made pass, and we look for code smells. And we determine solutions for these code smells, and these solutions are, in many cases, design patterns. We do that, and we then go back, and we write another test, and we make it pass, and then we look again, and maybe we have some duplication. Now it's probably the time to extract some common behavior during refactoring. And we do that both in the scale of a system, and in the scale of a module, and in the scale of a class. We look at our software, and we want to achieve, by the end of the refactoring phase, we want to achieve a system that is less sucky. But I've been mentioning this word refactoring quite a lot, but what does it mean? What is refactoring? So let's go ask the guy who literally wrote the book, what is refactoring? So Martin Fowler says that refactoring is the act of changing the implementation of a software system without changing its behavior. It's improving the design of our software in retrospect. And this is where emergent design happens. And this is why refactoring is such an important phase in software engineering. But sometimes we don't do refactoring. Sometimes we don't pay it the respect that it deserves because, we are pressured in time. The CEO wants us to launch a new product. There is an investor meeting. I'm going to get to it next week. No, you won't. If you do not refactor now, you will never refactor. You all know that. And it's a real shame because it's missing the whole point of TDD and it's missing the whole point of software engineering, because if our job is to introduce abstractions, then refactoring is where we do our job, is how we do our job. So if we do not refactor, we do not do our job. It's not an optional step. It's the essence of developing software using TDD. As your skills in TDD improve, your coding cycles will become shorter and shorter. And then what happens is this. You write a failing test. You make it pass. You refactor. And now you have a state that is completely clean. You don't have any code smells. You don't have any problems. Your tests are green. And now you write another failing test and you make it pass. How much code have you added? How many lines of code? 5, 10, 20? It's going to be very easy to identify code smells and to identify stuff that does not belong where you put it and where to move it. And this is the beauty of TDD. These short coding cycles make it very, very easy to add new stuff while maintaining a very high development velocity and without polluting the system. Now, it's really important to remember that test code is also code. And it's maybe even more important because if you think about it, it's fairly feasible to write software that takes a failing test and makes it pass. Actually, I've seen software systems that do that. They take a failing test and they generate code to make it pass. So 5, 10 years from now, our jobs might be obsolete. They probably won't, but you get my gist, right? But refactoring is something else. Refactoring is craftsmanship. It's a form of art. I don't think that anyone will ever be able to write software to refactor for you. Yes, you have in your IDE refactoring tools, but you, as a human, need to detect the code smells and tell it what to do, and then it executes the refactoring. So refactoring is our job. Refactoring is the most important step in writing code. And when we refactor when we write our tests and when we refactor our tests, we make our tests more maintainable. We make our tests more easy to read. And so if I were to take the entire production code of a system and delete it and start re-implementing it by making test pass, eventually I will get with a system that is equivalent to the system that I just deleted. But if my tests are unreadable, and if my tests are not easy to maintain, then I'm not going to be able to do that. So refactoring belongs in tests just as much as it belongs in production code, and maybe even more. We talked before about how we pick that first use case that we're going to develop. So whatever project that you're developing, you have a product owner. That product owner might be someone with the title of a product manager. It might be someone with the title of CEO. It might be yourself. It doesn't matter. Someone knows what we want to do. So we sit with that someone and we go over the list of requirements as we currently understand them. And it's important to note that it's as we currently understand them, because as we know, requirements are going to change. And we take and we enumerate and we prioritize these requirements, and then we pick the most valuable feature. It might not be the most important feature, and it might not be the easiest feature. It's the feature that is going to be most valuable for us right now. In the case of a library, a good first use case is going to be lending a book that only has a title. Why? Because then later adding other stuff to the book is going to be, a very small change. Adding author name, adding ISBN, not really much of a change from a book that just has a title. So we take that first use case, and we write that working skeleton. And we follow the rabbit hole, and we might find out that we didn't think about all of the requirements in advance, like they're going to actually be implemented in the system. So this is feedback from the test that we need to listen to. We need to go back to the product manager or the product owner or the CEO or whomever, and we need to discuss this feedback with them, and it might affect the way that we develop our software later. And if we fail to do that, if we fail to listen to feedback from the test, then we might find ourselves, at some point in a dead end because we didn't listen to the feedback. We didn't pay attention to what our tests were trying to tell us about the direction that our software is taking us. If we go back to that TDD lifecycle, it's not actually a cycle with 4 steps. It's a cycle within a cycle. In the first cycle, we pick the next feature, and then we start going test, code, refactor, test, code, refactor, test, code, refactor. And then we pick the next feature, and we go test, code, refactor, test, code, refactor. And if you've practiced martial arts or yoga or meditation, then you might recognize this as some sort of a cycle that has a meditative quality. And I think that this is something really beautiful. TDD will help you maintain a beginner's mind. What is a beginner's mind? When you're a beginner at something, you have less prejudice. You don't know anything, so you're not convinced that you know everything. So you're more open to new ideas and to criticism and to stuff that may contradict what you might have otherwise thought. As engineers, we are proud people. We are proud of our achievements. We are proud of our technology. We're proud of our knowledge. But this pride comes with ego. And this ego really makes it hard for us to learn new stuff. So maintaining a beginner mind will help you let go of your ego. It will help you shed off the pattern abuse and the over-engineering. And it will help you stay more YAGNI compliant. And hopefully, when you stay YAGNI compliant, your system will become easier to code, easier to maintain. You will maintain a faster development velocity. Your software will be better, and you will be less frustrated. Okay, thank you for coming.